Hello, my name is Amador and I'm about to present our code for a restaurant order management system database using MySQL Workbench. Um, First, of course, you gotta create database. This line creates a new database named Restaurant Order Lab. Ito po yung nag-serve as the main container kung saan po natin ilalagay lahat ng related na tables. And tables such as the customer, menu items, and the orders. Dito po ma-i-store yun and ma-organize. And then, syempre, use the restaurant lab order lab. And then, dito na po natin gagawin yung table ng customer. Ito yung yung statement na to, ito po yung nag-create ng table na named customers. And dito po ini-store yung mga customer information, yung like customer ID, nagde-define po as integer and nagsiset ng primary key. And then para po ma-ensure na lahat po ng customer ay may unique identifier. Then while yung customer name naman po, doon po ini-store yung name ng customer na may maximum 100 characters, and then the city store location na may 100 characters din. Ito po yung nagre-represent na kung saan po yung place na order ng people, yung nagpe-present ng people who will place the orders in the system. Then next table is create menu item table. Yung statement na to is nagke-create ng table na names menu items that holds all the available products in the restaurant. Dito po nakalagay din yung where item ID, yung nasa yung item ID, item name, item category, and item price. Dito po yung nagpe-present po ng list of items that customers can order. Then create naman po natin yung table orders. Dito naman po yung nagke-create ng table name orders na nagre-record ng every transaction made in that system. Dito rin po naka-store yung order ID with yung primary key, para may primary key po yung order ID para po syempre unique. Then customer na pangalan po ng customer na nag-order. Then item ID, yung ID po nung item na binili nila. And then quantity, number ng quantity kung ilan. And then order date kung kailan po nila in-order yung item na yun. Yun po. Thank you po for listening.
Hello po, I'm Jomar Aquino and I will explain my part. And in this code po, is used to insert sample data into a database and then run simple queries to retrieve and analyze that data, and it simulates a small food ordering system with customers, menu items, and orders. And after adding the data, it performs the different queries to display, filter, and sort customer information. And let's start the explanation for the code. And first in the code, in this code inserts the data into the customer's table, and each insert into customer's values lines adds one customer, and the values represent customer ID, name, and city. And for example is yung yung sa first line po, yung sa 1, Ana Cruz, and yung Laguna. And it means the customer ID po is yung 1, and is Ana Cruz from Laguna. And next is yung sa menu items table, and each row represents a food item, and the values are item ID, name of the food, and category, and the price. And For example po is yung this sa first line is yung 101 burger meals and yung 150 pesos. And after po nun is yung next na code is sa order table, and each order connects a customer to a menu item, and W are order ID, customer ID, and item ID, quantity and the date. And the example is yung 2001, 1, 102, 2, and the date is 2026, 3, or 1. In meaning means one ordered two burgers on March 1, 2026. And for the next, ano naman po, now the next part po is about queries on the customer's table. And the first query is select asterisk from customers and displays all customer records. And the asterisk means ano po, get everything. So it shows all columns and rows. It's like ano po, opening the full list of customers. And the second query is select distinct city from customers and shows only unique cities, and the keyword distinct removes duplicates. So even if many customers are from Manila, it will only show Manila ones. And this is useful po when you only want a list of different locations. And the third query is select asterisk from customers where city equal to Laguna. And filters it filters customers based on a condition. And the word keyword is used to set a condition. So this only shows customers who live in Laguna, and it's like searching with a filter. And the fourth query is select asterisk from customers where customer name like A, then and percent. Searches for names starting with the A, and the like keyword is used for pattern matching, and A percent means start with A, and the percent symbol means any characters can follow. So this is will return names like Anna or Alex. And the fifth query is select asterisk from customers order by customer name ascendant. And it sorts the result alphabetically by name. And the order by keyword is used for sorting. And ascending means ascending A to Z is like arranging names in alphabetical order. And that's it. And for the logic and the ideas, this code this does not use loops or complex conditions, but it shows basic database operations, like inserting data, filtering, removing duplicates, searching patterns, and sorting. And these are very important for working with databases. And that's all. Thank you.
My name is Jose Paul Aparice. So for table 2, which is our menu items, we created different queries to retrieve and organize the data based on the specific condition. For the display all menu items, first we use the select all from menu items to show all the data in the table. So this gives a complete view of every menu item, including all columns like name, price, and details. So next is the items within price range 100 to 300. So we filtered the items using between 100 and 300. This means we only display the menu items whose prices fall within that range. So this is useful when we want to focus on mid-range price items. So next is items with price greater than 200. So here, we use a condition price is greater than 200 to get only the more expensive items. So this helps to identify the premium or high value products. So next is sort menu items by price to highest to lowest. For sorting, we used ordered by price desk. So this arranges the menu items starting from the most expensive down to the cheapest and making it easier to compare price quickly. Then for the display, first 5 menu items, we used limit 5 to only show the first 5 records. So this will help full when we don't need the full list, especially for previous or performance optimization. So this queries demonstrates how we can retrieve, filter, sort, and limit data efficiently from the menu items table depending on our needs. So that's all for table 2.
Bengal greetings from Ma'am Cyril. I'm Alvarez Lab S, and today I'm going to explain our midterm lab exam, MySQL. So as you can see here, this table 3 is orders queries. Basically, these are SQL queries that pull different kinds of information from an orders table. Here's each table does. So TC1, this counts every single row in the table. So TC1 is basically a asking how many orders exist on total. And next on, we have TC2, calculate total quantity ordered. Um, Basically, this just adds up all the values in the quantity column across every order. Basically, it gives you the grand total of all items ever ordered. Going on to TC3, find the largest quantity. So this scans the quantity column and returns the highest highest value, only the single highest value. It's useful for if someone orders a large quantity, it's gonna spot the biggest order ever placed. And next on we have TC4, which basically it acts like a filter. It filters rows by date, returning only orders that fall between March 1 and March 1 to 5, 2026. The between keyword is inclusive. So both end dates are included. So both are included. And next on we have TC5. It counts orders per customer. This is the most interesting one because as you can see, it uses group by, cluster all orders by customer ID. Then it counts how many orders each customer has. So instead of one big number, you get a breakdown like the customer one has 4 orders, and customer two has 7 orders, and basically it's so on. The pattern you'll notice is that TC1 to TC3 uses aggregate functions. Aggregate functions, for example, you have count, sum, and max to crunch up the whole table into a single number, while TC4 filters rows, and the last one, TC5, it combines grouping with aggregate to get per customer summaries.
Okay, so for this last section, we're going to look at what we call combined queries. And we're gonna use the union keyword for all the 5 test cases. So basically what union does is that it takes the result from 2 separate select statements and stack them into a single list. So one thing to keep in mind is that union automatically removes duplicates. So if the same value appears in both tables, it will only show once. So let's get over through each of the test cases. So to start off, um, we need to combine the customer names and item names. So for our query, we used, and let's select the customer name As restaurant entities, this will be the name of the column from customers, and union to select item name from menu items. So let's run. This is the result. So so for the first query, we're combining the customer names from our customers table and the item names from our menu items table. We alias the first column as restaurant entity, so the output has clean label. When you run this, you'll see one column that has names like Ana Cruz, Ben Santos, and then below that, burger, pasta, steak, all in one list. The reason this works in both is both columns are text, so Union has no problem merging them. So for the next, we'll combine customer cities and menu categories. So for the second one, we're doing something similar, but now with cities and categories. We're pulling the city column from customers, so Manila, Laguna, Batangas, and combining it with the category column from both items. So meals, like meals, drinks, snacks, again, both are text, so it merges cleanly. And since Union removed duplicates, if a city name happened to match a category name, it would only appear once. The output column is labeled combined list. So here, combined list. So let's run here our combined list. So next, for the customer IDs and union to item IDs. Now this one is a little different because we're combining numbers. Customer IDs go from 1 to 10 and item IDs go from 101 to 110. Since these are all integers and none of them overlap, Union will just stack them all together into one column called restaurant IDs. You'll see the numbers from both tables listed out, no duplicates since none of the values are the same. So um, right here, as you can see, it just stuck all together. The next, customer names union to order IDs. This one is a bit trickier because we are trying to combine customer names which are text with order IDs which are numbers. The problem is union requires both columns to be the same data type. So what we did is we used cast to convert the order ID into a character, basically turning the number into text so it can be combined with other names. Once that's done, the output will show customer names first, then the order IDs like 2001, 2002, and so on, all in one column. So right here, all stuck together. So next, cities union to order dates. The last one is similar. We're combining cities from the customer tables with order dates from the other orders table. Dates are stored differently from plain text. So we use cast again to convert the order dates into characters. That way, Union can merge them without any type mismatch errors. So the result is one column showing city names like Manila and Laguna, followed by dates. So here. And again, all stacked together. So that wraps up the combined query section. The main thing to remember with union is it only works when both select statements have the same number of columns and compatible data types. That is why we use cast in the last two queries just to make sure the data types matched up. And by default, union removes duplicates. So if you actually want to keep them, you'd use union all instead. That is for our presentation. Thank you very much. Thank you for listening.